Hello students. So solutions. This chapter is very important chapter. Why? Because if anything, if you want to express in terms of concentration, like how much is dissolved in a particular solvent, definitely you should have the information. You should know the knowledge about solutions, the methods of expressing the concentration. So first of all, to start the discussion about a solutions chapter. So what is a solution? Like a homogeneous mixture of a substance in another substance. Like if two components are mixed together, they can form solutions. Mixed means like how they can mix. What's the meaning of mixture? For example, when hydrogen gas is mixed with oxygen gas, if you maintain certain conditions of temperature and pressure, we can get H2O, water. Is it the mixture? Is it that combination? Together, are they forming solution? The answer is absolutely no. Means, what is the difference? When hydrogen gas combines with oxygen gas, it produces water, which is a chemical combination, that is not called as a mixture. Why? Because a new substance is getting produced. Yes, sir, students. If the components are chemically combined, it is not called as a solution. First of all, this point. Then when it is called as a solution? When the components are combined physically, only physical combination. Physical combination means they do not form any chemical bonds. Nothing, no new substance is getting produced. Then only it is a physical combination. Then only they can form the solutions. For example, salt is added to water. Does it produce any new substance? No. No, that is what the physical combination is. Nitrogen gas reacting with hydrogen gas produces ammonia. Is it a physical combination or chemical? That's a chemical combination. Can we call that as a mixture? No. No, that is not called as a mixture. The reaction, chemical reactions are not mixtures, students. Chemical reactions. Why? Because they produce as a completely new substance. So what is a mixture? When components combine physically. Physically means simply they coexist together. They have their own properties. Simply they coexist together. How do they coexist? That also we'll discuss in this discussion. So what is a solution? A homogeneous mixture of a substance in another substance is called a solution. That means something is mixing in another chemical. A component is mixing in another component. So here, if you want to divide as a solution, we have two types, two components here. One is called as a solute, other one is called as a solvent. So what is solute? The substance that is present in a relatively smaller, relatively means comparatively. If anything in the solution, if one component is in smaller quantity and another component is in higher quantity, the smaller quantity is called as a solute and the higher quantity is called as a solvent. Got the clarity, students? What is solute? The component which is present in smaller quantity is called as solute and the component which is present in higher quantity is called as solvent. Got the clarity? That is solvent. Some students have the doubts like, sir, what if they are both equal quantities? Yes or no? So, but in general, students, in general, where do we use all this information, all this knowledge, volumetric analysis for the titrations, for synthesizing medicinal industry, syrups are made, yes or no? Tablets were made, yes or no? By dissolving. In this process, definitely, for sure, both were not maintained in equal quantities. Definitely one is lower, one is higher. If you have this kind of doubts, in general, liquid is considered as a solid. In general, like if that is the point, and solid component which is produced will be liquid solute. If both are liquids, in general, water is considered as a universal solvent. If you want to divide the things like this, there is no end. So remember, the component which is present in lesser quantity is called as is treated as solute, which is present in higher quantity is treated as solvent. Solute plus solvent together forms solution. That means solution is made up of two components or two or more components. The components which are dissolved in another component, which are lesser quantity called as solute or solutes, or heavier quantity is called as higher quantity. Heavier means in the sense higher quantity is called as a solvent. Next, concentration. The amount of solute dissolves in a given quantity of solvent is called as a concentration of the solution. Concentration is also very important, students. Concentration means, okay, a solute is dissolving, but how much of solute is dissolving? In 100 grams of solvent, how much is dissolved? In 1 liter of solvent, how much is dissolved? In 1 liter of solution, how much is So there are different types of concentration expression. There definitely we should have one parameter, yes or no? We should have one reference. In 1 liter, how much is dissolving? That is called as concentration, and this concentration can be expressed in n number of ways. Students, like mass percentage, volume percentage, molarity, normality, formality, all we'll discuss in this chapter called as solutions. So what is concentration? In general, if you want to define concentration, the number of moles of solute in a unit solvent or in a liters of solvent or solution is called as concentration. So the solvent, the amount of solute present in a given quantity of solvent or solution. If it is a solvent, we have one more expression. If it is a solution, we have a different expression, but ultimately all are called as concentration only. Next, what is the process of dissolution? The solute dissolves in the solvent, giving a solution. So I am saying that physically combined, physically coexist together, dissolving. So what is the meaning of dissolving? For example, salt added to water, salt dissolving in water. So during this process, what happens, students? Like the moment when you add the salt in water, the salt molecules will disappear. Yes or no? Where they are going? Where they were gone? Where the salt molecules were gone? What is happening? What is the meaning of dissolving? You know what is happening? You already know. Water molecules have some spaces between them. Yes or no? Water is a liquid. Have some spaces between them. The moment when you're adding salt, these salt molecules, NaCl molecules, are getting into the spaces between the water molecules. They are entering into the space. Sir, why they are entering? If you add oil in water, why oil is not entering? Why? Because, students, the reason is density factor as well as forces of attraction. Water is a polar covalent compound. Water, H2O, oxygen contains partial negative charge, hydrogen contains partial positive charge. The moment when sodium chloride is added to water, sodium is sodium ion, yes or no? In sodium chloride, chloride means Cl minus, right? In sodium chloride. So these sodium ions were attracted towards a partial negative charge of oxygen, and the chloride ions are attracted towards partial positive charge of hydrogen. That's why this attraction is there. But oil or petrochemicals, diesel, these are all organic compounds which they don't have that much of polarity, so that's why they are not soluble in water. Understood what is happening during solubility? Dissolution means what? They are developing these forces of attractions. That's why they are simply getting into the spaces between the water molecules. That is what happening during dissolving. Are they developing new chemical bonds? No, this is simply weak forces of attractions only. So that is what about the introduction about solutions, students. Next, we have some types of solutions, and these types are based on different categories. So first, classification of solutions based on solute quantity in solution, right? This is also very important during the laboratory analysis. We have a dilute solution and concentrated solution. This classification is also relatively classified. Relatively means by comparing with another solution. For example, students, we have a glass of an acid, okay, a glass of an acid, and we have a glass of water, right? Take the third glass and take like half glass of water and half glass of acid. Mix half glass of water, half glass of acid. Make that as one solution. Both are mixed, yes or no? Physical, right? Correct. Now take 3/4 of acid, 1/4 of water, and make one more solution. Understood? What is the first sample? Half glass of water, half glass of acid. What is the second sample? 3/4 of acid and 1/4 of water. Now see, now you can say it now. Which is concentrated, which is diluted? First one is diluted, relatively, comparatively. Second one is concentrated. Sir, why? How can you say second one is more solute, more acid is there, less water is there? Yes or no? And in the first case, equal amounts are there. Comparatively, comparing with the second sample, more water is there or not, students? Simply, if less acid is there, more water is there, then that is dilute. If more acid is there, less water is there, that is nothing but concentrated. So mostly we use these terms of dilute and concentrated for acids and bases only. If you want to define in general, a dilute solution is a solution in which the solute quantity is small in the given mass of a solvent. Concentrated means solution in which the solute quantity is large in the given mass of a solvent. Relatively, students, large means more, but relatively, comparing with the two solutions, then we can identify whether it is a dilute solution or concentrated. Concentrated means, in general, remember, in terms of acids, more acid, less water is concentrated. more water, less acid is dilute solution. This is the classification in terms of based on the solute quantity present in the given solution. Next, classification 2. This classification is based on the amount of solute dissolved in a particular solution. Amount means how many grams it is dissolved. Like we have saturated solution, unsaturated solution and supersaturated solution. First, saturated solution. A saturated solution is a solution that cannot dissolve any more solute at a given temperature, that is called as saturated. For example, students, for example, in a classroom, your classroom maximum capacity is like 50 students. If all the 50 students were there, the classroom is completely filled. What is the classroom capacity? 50 students. Now classroom is 50 students with completely filled. Now you can say that classroom is saturated. That's it. I think you already got the idea. Now apply the same concept here to the saturated solution. So what is saturated solution? If anything reached up to its limit, then that particular thing is called as saturated. Here also in the solution, take a glass of water. Do you think in this glass of water can dissolve any amount of salt? No. There is some particular level, yes or no? If it reaches that level, if all the salt is completely dissolved, where no more salt can be dissolved into the solution, that level, that solution is called as saturated. Sir, why no more salt can be dissolved? I already told you. What is dissolution? When salt is added into the water, these salt molecules are going into the spaces between the water molecules. Yes or no? If all the spaces are completely filled, can more extra salt is added? No, we can't add. So that's why that case is called as saturated solution. Now answer, what is, once again, what is saturated solution? If no more solute can be added to the solution. Why no more? Why? Because it is already reached its level. Already the dissolution reached its level. For example, take a glass of water. This glass, for example, let's say it can dissolve maximum 5 spoons of salt. Let's say for our understanding, 5 spoons of salt. You already added 5 spoons of salt. If you add the 6th spoon of salt, what happens, student? Does it dissolve? No, that will settle down. Yes or no? You can dissolve more solute into that solution. No. What is the maximum? 5 spoons only. Already 5 spoons were added and dissolved. That solution is called as saturated. No more solute can be dissolved into the solution. It's called as saturated. With this saturated definition, you can easily define unsaturated. What is unsaturated? In the same classroom, if only 20 students are there. Now the class is unsaturated. Is it maximum level? No, it is less than the saturated level. Yes or no? That is unsaturated. That means more student can be added to the class or not. Similarly, apply the same concept to the solution. More solute can be added to the solution. That solution is called as unsaturated solution. Let us take the same example. A glass of water, maximum 5 spoons of salt. If only 3 spoons are dissolved. Now the solution is saturated or unsaturated? The solution is unsaturated. Why? Because you can add extra 2 spoons of salt. Yes or no, students? Got the clarity? If you add the 2 spoons, now the solution becomes saturated. But until the 5 spoons are completed, the solution is still unsaturated. What is the meaning of unsaturated? More solute can be added into the solution is unsaturated. Next, third type, supersaturated solution has more solute than that of saturated solution at a given temperature is called as supersaturated. That means, students, which means maximum a class level, I said 50. If you can able to add few more students into the class, now the class is more than its level, yes or no? Then that class is supersaturated. How can we add more students, sir? Let us apply in terms of solution. Let's take the same example, glass of water with 5 spoons of salt. I want to dissolve 2 more spoons of salt. If I can dissolve 2 more spoons of salt, then the solution becomes supersaturated. But sir, but how you said no, the whole molecule, the spaces were gone, filled completely. Then how can we make a solution into a supersaturated solution? Students, by heating. Heating means not completely like boiling, all the water will evaporate, not like that. By gentle warm, like by small heating. If you're providing some temperature, what is happening, students? If you provide some temperature, the molecules gains a kinetic energy or not? If the molecules gains kinetic energy, what happens to the molecules? The molecules will expand. If the molecules will expand, that creates new spaces or not? If the molecules will expand, then extra salt is added into that spaces or not? Now the solution becomes supersaturated. Understood? Got the clarity? by temperature condition, by pressure condition, we can also make a solution supersaturated. What is the meaning of supersaturated? A solution which dissolves more than its saturated level. More, maximum is 5 only, but we are dissolving extra 2 spoons of salt. Why? By heating. What is happening by small heating? What is happening? The molecules are expanding, creating new spaces, and that makes dissolving extra added salt. Okay, now keep that solution aside, like until all the temperature was gone, extra added temperature was gone. Let it reach the room temperature. Now what happens, students? Now what happens? Like, does it still the supersaturated? No. If the temperature is gone, the extra added salt again crystallizes. Understood? Got the clarity? Again it becomes a saturated solution. When we can maintain that supersaturated, we have to maintain the temperature, you have to maintain that spaces. If the temperature is lost, again the molecules come closer at the room temperature. Got the clarity? Saturated, unsaturated and supersaturated based on the amount of solute present in. Next, third type of classification here we have is based on physical state of solute and solvent. Physical state means solute means solvent. You already know what is solute, smaller quantity, solvent is higher quantity. So physical state means solid, liquid and gas. We have all these possibilities, students, like we have solid in solid, liquid in solid, gas in solid. We have liquid, solid in liquid, liquid in liquid, gas in liquid, as well as we have solid in gas and liquid in gas and gas in gas type of. Total all these possibilities, all the 9 possibilities we have. Let us discuss one by one. First, solid in solid type of solutions. So do solids combine? How do they combine? How do they can form the solution? Right, correct, students. Solids they won't combine in general. Combine in the sense like completely together they cannot form the solution. But when you melt solids, then they can be converted to liquid now. Correct. Again, after melting, if you mix these two metals, they will mix in the fused state, in the melted state, molten state. Again, if you solidify, now that is a solid. Now that solid contains a mixture of metals or not, students? That is what the solid-solid combination. Generally, we have the examples as alloys, and this type is called as solid in solid. Why? Because here the smaller quantity is solid, higher quantity is also solid. So this type of solution is called as solid in solid. Example, brass, bronze, all these types of alloys. Alloys are there, students. Copper and zinc, copper and tin, stainless steel, iron, carbon, chromium, manganese steel, tungsten steel. So all these are the combinations of solid in solid only. All are solids only, na, students. So that type of combination is called as alloy is an example, and here it is called as solid in solid type of solution based on the physical state. Next, we have liquid in solid, right? Liquid in solid is called as liquid in solid type of solution. How it is possible? How can we have this liquid in solid amalgams? Mostly mercury. Look at here, mercury in silver or cheese is an also example of liquid in solid. Which is which is higher quantity, which is smaller quantity here? Liquid is smaller quantity and solid is higher quantity. Yes or no? So that's why it is liquid in solid, and amalgam, mercury is a liquid, silver is a solid. So all these type of solutions where the mercury is involved in the alloys, in general amalgams. Of course, there are different types are there. We have sodium amalgam, gold amalgam, but they are definitely liquid quantity should be low and solid quantity should be high. Then these examples comes under this type of solutions where liquid in solid. Cheese also an example of this type. Next, gas in solid. Is it possible gas completely dissolves? Look at the example here. H2 in platinum or palladium, hydrogenation reaction, students. During these reactions, when you add these least reactive metals like nickel or platinum or palladium to the hydrogen gas, these hydrogen molecules, hydrogen is a gas, platinum or palladium is a metal, is a solid metal. These hydrogen molecules are completely absorbed by the metal surface. So this combination, they are not reacting. That's not a chemical reaction. During this process, nickel platinum acts like a catalyst. So they completely absorbed onto the surface of nickel or platinum or palladium. This combination, this mixture comes under gas in solid. Or also we have some type of volcanic rocks where the gases are trapped inside the porous material of the rock, which they can easily float on water. Yes, or no, floating rocks. That is also, we can get the example here in this type, gas in solid. Next, solid in liquid. So solid in liquid, that's a general combination. Yes or no? Salt in water, sugar in water. All these are the examples of solid in water, solid in liquid combinations only. So right. Next, liquid and liquid combination, we have benzene and toluene. So benzene and toluene are like complicated chemicals to this level. So general examples, milk in water, yes or no? Alcohol, water, both are liquids and liquids, yes or no? Mostly medicine syrups. What is there? What is the statement there in the syrup, students? Shake well before use. Why? Why? Because it is made up of different components where they can form, different layers, yes or no? Over the long period of time they can sediment. So that's why different liquids are there in the syrup. So that is also liquid combination. Emulsions, liquid combinations. Paints also contains different liquids are combined. So next, and even as well as petrochemicals, petrol, diesel, what they are made up of? Are they made up of single chemical? No, they are made up of like octane, heptane, not butane, octane, heptane, nonane, different chemicals are completely mixed. That is also a liquid and liquid combination. So next, gas and liquid. So like how gas can dissolve in water? Yes, gas can dissolve in water. For example, or drinking water. Drinking water, do you think only water is there, only H2O? No. Some oxygen is also there in that, which is in the dissolved state, and this is the reason for the survival of aquatic life. Or for example, you're drinking the soft drinks, carbonated drinks. So what is there inside the carbonated drink? Carbon dioxide dissolved in that sugar solution. Yes or no? That is gas, right? Which is dissolved into the liquid, right? So that is gas in liquid combination. In general, oxygen in water. Next, solid in gas. How solid in gas, right? Solid. For example, road sometimes the vehicles releases black smoke, yes or no? Why? Because some damaged vehicles where they are not running perfectly. So what is this black smoke contains? Carbon dioxide is there, but the blackness is coming because of insufficient amount of oxygen, incomplete combustion. That black is pure carbon particles are released into the atmosphere. Of course, they can cause harmful effects, but this carbon is a solid, right? Into the air. Now here carbon is a solute, air, atmosphere is a solvent. Now carbon is a solid and air is a gas. So solid in gas combination. Is this carbon smoke? Yes or no? Carbon in air, and dust particles in air also comes under this example, this type of combination. Next, liquid in gas, fog. Liquid in gas, right? Mist, or some, if you spray something like any perfume or anything, these liquid droplets are simply scattered into the surrounding air for some time, yes or no? So that is liquid. Fog is the best example. During winter seasons also we can see the liquid droplets are falling down. So that combination, liquid in gas combination, which is fog. Gas in gas combination, right? That is the best example is air. Air is made up of composed of different gases like nitrogen gas, oxygen gas mainly, and other gases like argon and other hydrogen. Some examples, some other gases like helium and other noble gases are present in the air. Water vapor is present. So all these gases are they chemically combined in the air? No, they simply physically combined only. All are gases, right? Gases and gases. Like only this end we have only oxygen gas, this end only we have nitrogen gas. Are they like that? No, they completely mixed. Yes or no, student? This gas in gas combination, but air is the better example. So this is the third classification based on the physical state. Next, fourth classification based on the type of solvent. Based on the type of solvent. Solvent means which is present in the higher quantity, right? We have two types. One is aqueous solutions and non-aqueous solutions. Simple. Aqua means water. If water is a solvent, all the solutions comes under aqueous solutions. If other than water, if any other solvent is there, then that comes under non-aqueous solution. Got the clarity, students? Water, aqueous solutions. If water is a solvent, is called as aqueous solution. Other than water, anything. Sir, water, other things like benzene, like ether, like kerosene, like petrochemicals, carbon tetrachloride, all other components which can act like a solvent, alcohol, all comes under non-aqueous solutions only. Non-aqueous means they are not simply water, other than water. Got the clarity? So for example, sodium chloride in water, is it aqueous or non-aqueous? Aqueous solution. Sugar in water, aqueous solution. Iodine in alcohol, is it aqueous or non-aqueous? That is non-aqueous. Wax in kerosene, is it aqueous or non-aqueous? Non-aqueous. Understood, students? Organic compounds in organic solvents are all non-aqueous solutions only. Water, aqueous. Without water, no water. Other than water, any other thing, non-aqueous. Right. So all these are the types of solutions. We have concentration terms, students. First one is solubility. What is solubility? The maximum amount of solute that can be dissolved in 100 grams of solvent to form a saturated solution at a given temperature is known as solubility. That means students, I already told you, concentration terms we can express in n number of ways. Sir, how n number of ways? In 100 grams of solvent is one expression, in 1000 grams of solvent is another expression, or if it is in terms of solution is different expression, 1 liter of solution is like different ways we can express concentration. This is the solubility factor. What is the formula? Weight of solute divided by weight of solvent into 100. So this is called as solubility, students. How much? In 100 grams of solvent, how much amount of solute can be dissolved to form a saturated solution. For example, 4 grams of sodium hydroxide is dissolved in 40 grams of water to form a saturated solution. Calculate the solubility of sodium hydroxide. What is the formula of sodium hydroxide? NaOH, sir, no. How much it is dissolving? 4 grams of dissolving in how much? 40 grams of water. Then what is the solute here? 4 grams is the solute, which is sodium hydroxide. What is the solvent here? Weight of solvent. What is the solvent here? How much? 40 grams. That means 4 by 40 into 100. That's it. That's the expression. Weight of the solute by weight of the solvent into 100. 4 by 40 into 100, which is equal to how much? 0, 0 cancelled out, which is equal to 10. So what is the solubility of sodium hydroxide in water? 10. The solubility is 10. This is a very simple expression, solubility. Like solubility, we have different expressions like mass percentage, volume percentage, mass in volume, ppm, parts per million, molarity, molality, normality, formality. All are concentration expressions only, but different units, different parameters, different references we have. So all these we'll discuss in the coming video. So that's all, students. For in this video, what we discussed about what is the solution, what happens during dissolution, what is the definition of mixture, what are the types of classifications we have, and these classifications are based on different categories. All the types clearly we discussed. That's all for today, students, in this video, and we'll meet in the next class. Thank you, students.